Welcome to the physics lab. We are here today to talk about
Ohm's law.
Ohm's law. Ohm's law is very simple. Ohm is where the art is. I thought that was pretty good. So how do we do this lab? Well, the first thing we do is we read the lab manual, which I hope you did. Did you read it, Bibu?
Yeah, I did.
Okay, good. Bibu is going to be my assistant here for this video. If anything goes wrong,
It's my fault.
it's his fault.
Take it.
All right. Now, so first of all, let's take a look at the setup of the lab. All right. Here we have our power supply. As you can see right now, it's set to 0. All right. We can also set it by just turning it off and turning it on. Make sure I check it before you turn it on. I don't want anybody turning this on without me checking it first. So here we turned it on, right? But this is how it's set up. We have the red wire going into the current probe on the red line. The black wire comes out and goes to the resistor. All right? The other black wire comes out and goes straight to the ground, or the negative terminal on the power supply. Now, these two clips here, these two alligator clips, this one here goes to the same one, the output of the current. This is the voltmeter, differential voltage. So the red one goes to the output of the current meter, and the black one goes to the other terminal. All right? This is all set up. We plug it into the Logger Pro. I'm sure most of you are familiar with the Logger Pro. And you have the current probe into channel 1 and the voltage probe into channel 2. Now, let's see who can remember this. What does it mean if your connectors don't fit? It doesn't work. No.
It doesn't go in.
No. It means you put them on the wrong side. It does not go on the Digisonic side. It goes on the channel 1, channel 2 side. Don't screw it up. Okay? Okay?
Okay.
All right. Thank you. All right. So now, if you come on over here, the Logger Pro setup is a little bit different because we have this button here called Keep. All right? Now, if you took 20L, like most of you did, we didn't have this button on. It's a different setup for Logger Pro. And the way it works is, if we turn this thing on, which we did, and we change the voltage, why don't you focus on the screen there, Marcus? You're going to change the voltage, and you're going to watch one dot move back and forth. Ooh, up. And then we're going to get it right around 4 volts. Now you see up here it tells you what the voltage is. Right there is 3.914. All right? So we want to get it to 4 volts exactly. You don't pay attention to the what it says on the power supply, just on the Logger Pro. And there's a big one actually. It's really big right here. 4 volts current. So we get to about 4.02. That's close enough. And then you hit the keep button, and it'll stay there. Now we go to 4.5 volts. Close enough. And we hit keep on this too. And you see it was right there. Okay, that's how you take your data on this one. It's really easy. Isn't it? Now as you notice here, you can take the data from here, the current and this stuff right here, and copy it. And I'm just going to paste it into any Excel spreadsheet. I don't have the Excel spreadsheet set up yet. Whoa, don't do that.
You did only 3 points earlier. Why don't you have so many points?
I did a couple points before the video started, by the way. Yeah, I was testing it out beforehand, okay? So but you can take points real quick that way. All right. Anyway, so for the first, I think I said on the first part, what I want you to do is put all the data into the Excel spreadsheet for the lab and plot it. But after that, for the second part, when we're going on to a light bulb, then you're just going to do everything right on here. And what you can do is you can copy the picture, hit Control C, and then you can go on to anywhere, and you can just paste the picture. That's not working, and I don't know why, but let's just pretend it did for just a minute, all right?
Paging the workshell. That's a text file.
Well, it's not.
Text and buffet.
Okay, it's not letting me copy for some reason.
That's a spreadsheet. How can they let you take the graph?
You can. I did it before. Either, yeah. Well, if it doesn't work, it doesn't work. Maybe it's set up on this particular one. Anyway, one thing you need here is to use the linear fit. All right, and it's waiting. I don't know what it's waiting for. Maybe I have to hit stop
How do you
first.
put
Yeah.
the linear fit?
You see that one there that says R equals? That's a linear fit.
You click the linear
Yeah,
fit.
right there. Okay, for those of you who took 20L, remember that, don't you, Mark?
Yep.
Okay. And then it gives you the slope, 47.68 volts per amp. That is going to be your resistance. It's that easy. Your intercept should be what? What do you think it should be close to?
0.
That's right, 0. Okay? So then you could do that. Now take a look at this resistor. It says, what does it say on here? What's the resistance say? 47, and then with some weird symbol that looks like it's a fraternity.
Ohms.
That's an omega, which means ohms. And we got a slope of 47.68. So I think we can say that our resistor is working.
They have plus or minus 10%. I think 10%.
Well, some of them are plus or minus 5%. You can buy them 1%, 5%, 10%. I actually built a system in Pennsylvania for a resistor sorting machine, and it would sort up to 15,000 resistors an hour. Where it would take a measurement of the resistance and put it in a bin depending on the resistance value. Then they would take the ones that were within 1% and they'd sell those as 1% resistors. The ones that were within 5% outside of that and sell those and so forth, because they got the better price than the 1%ers. Okay, so then we're all done with this one. Okay, so now, very important, in the interest of not electrocuting yourself, I said you, don't electrocute yourself. What you want to do is, when we're going to do this next part, you have to turn the power off. All right? So then we take the resistor out, and the actual resistor you see is in here. This is just a big piece of plastic. All right? Yeah. That was a good catch, don't you think? I think so, and I'm right. And now we're going to put this guy in here. We're going to put a light bulb in instead. Now that's a bright idea. You're supposed to laugh. Okay. Now, what you can see is when we turn the electricity on, what happens? The light bulb lights up. But let's put it back down to 0 volts, and you see the light goes out. And now, let's go back over to Logger Pro, clear the whole plot, if I can figure out how to do that easily. Yeah, so how do I get rid of all this data? Oh, that's not it either.
You just delete them, just highlight, delete.
That wasn't a good idea. All right. Well, that gives me an opportunity to show you where you can find the file. It is in the Physics 21L folder, and it's Lab 2 Ohm's Law, and it's 25 Ohm's Law. All right. So now it's back here again. Now we hit collect again, and we're going to do it with the light bulb. All right. So, Biba, could you every once in a while hit keep on there?
Yeah.
Because watch how fast we can really take this data. All right. Just hit keep about every 1
3 or 4
second.
seconds. Okay.
I'm just going to slowly increase the voltage. See, I'm slowly increasing it while Bibu is clicking the mouse. Now I'm going to decrease it. It'd help if Bibu clicked a little bit different, so we wouldn't end up with the points being right on top of each other. But, he is kind of incompetent. I know. Some of you have had him as a lab partner before, so you know just what he's like.
Okay.
Let's go a little bit on the low end right there. See, this is kind of weird. The behavior down at the low voltage is kind of strange. But then again, Bibu's behavior is kind of strange
They
too.
will be non-linear after they go too low.
All right. Now, actually, I want you to be more careful when you take your data.
It has to look like exponential or something.
There, got that one in the middle. So you can get a lot of data real quick here. And since we don't need to copy this over to Excel, it can be done in pretty quick time. Right? And what you see though is, what'd you see here? What'd you see? What'd you call that? What do you call that behavior?
Linear fashion.
What's it called? It's not linear.
It's a relative. It's called.
Looks quadratic.
Oh, you talk.
Yeah, what is it? It's non-linear.
It's exponential
Talk
going
about
straight.
exponential.
But either way, the point is that the light bulb doesn't act like the resistor. The resistor stayed linear the entire time. The light bulb doesn't. Why? Why is it doing this to us? Do you know? Think about it. Now, the next part talks about using diodes and LEDs. Oh, I'm sorry. No, we got to do the reverse.
Oh, you talk about this certain breakdown region.
Yeah, don't stop. Shh. My video. Okay. Now in the next part, what we do is we turn this off again, and now we're going to put the resistor in the other direction and see how that works. Okay. And the next part it says we're going to do the same kind of thing with diodes and LEDs and Zener diodes, but we're not going to do that. We're going to stop at the reversing the resistor. Okay, you got that? And I'll see you in the physics lab.
Password.